Welcome to my channel, and here I'll be showing you how to construct an epicycloid. Which is one of the special curves that we have in engineering drawing. For you to construct an epicycloid, there are three things that you need. Number one, as I've written it here, is the radius of the rolling circle through which the curve known as epicycloid will be generated. Then we need the radius of base circle or directing circle. Either we call it base circle or directing circle. So we need the radius of base circle, as I said, or directing circle. Alright, then we need the angle between a point on the circumference of the base circle and the other point on the circumference of the base circle. You are going to get what I want to explain here, and what I meant by the point on the circumference of the base circle and the second point on the circumference of the base circle. Okay, now for the radius of rolling circle, I'm using 25 millimeters for that, and the radius of base circle or direct circle, I'm using 75 millimeters for that. Then the angle that we need, okay, so the value of the angle is calculated with this formula that we have here. So theta is equal to radius of rolling circle over radius of the base circle multiplied by 360 degree. So as we have here 25 over 75 multiplied by 360 degree gives us 120 degree. So now we can go and begin to work on how to construct an epicycloid. So what we need to do first, so we are going to have a point here. I'm going to put a point here. Then take your 45 degrees set square. So it is advisable that you make use of your 45 degrees set square, and then you draw a line from this point. So draw a line in this direction like this. Okay, so let's label this point as point O here. Okay, so now the next that we are going to do is to take our protractor. So we take our protractor and we set it like this on this line. So make sure the midpoint of the protractor is at point O, as I've shown it before. So set it, and the horizontal line that we have on the protractor, let it be on this line that we drew. Then take a measurement. So a measurement of 120 degrees. So this is 120 now. Then we are going to divide this 120 into 12 equal parts. So if we divide it to 12 equal parts, that means we are going to have 10 degrees each. So this is 1. So this is 2. So just dot this. So this is 3. So this is 4. This is 5. So here is 6. So we have 7. This is 8, 9, 10, 11. Then we have 12. So those are the 12 points. Now, having done this, the next that we are going to do is that from point O, draw a line through the 12th point. So let's leave the rest for now. So draw a line through the 12th point like this. Alright, so then the next thing that we are going to do is to take our compass, and we take a measurement of 75 millimeters, which is the radius of the base circle or directing circle. So we take 75 millimeters on the ruler. So this is 75 millimeters here. So this is 75 millimeters. So put the midpoint of the compass at point O here, and you draw an arc like this. So this arc is the circumference of the base circle. This arc is the circumference of the base circle, and it's upon it that the rolling circle is to roll for us to generate a curve that is known as epicycloid. Okay, so then, so this point here, so we are going to call it point P. So we call it point P. Okay, then the next thing that we are going to do is that we are going to take the radius of the rolling circle, which is 25 millimeters. Okay, so we put at this point P here, and we make an arc here on this line. Then we put the midpoint at this point. Then we draw a circle to touch point P. Then we draw a circle like this. So we have drawn the circle. This is the rolling circle. This circle is to roll on this arc. That is the circumference of the base circle or directing circle. So if it rolls on it, it's going to give us the curve that is called an epicycloid. Before you can go on to generate the curve, so we need to divide this circle into 12 equal parts, as we have divided this into 12 equal parts. Or if we divide the circle into 12 equal parts, we need to divide this arc into 12 equal parts. So with a 45-degree set square, so I'm going to divide this circle into 4 equal parts. Already divided into 2 equal parts. So I will draw a line from here to here. Okay, then I will take the radius that I used to construct this circle. For me to divide this circle into 12 equal parts, that radius 25 millimeters, I put at this point, and I make an arc here. So make an arc at this point. Then putting it at this point here, we make an arc here, and then we make an arc here. Then I put at this point, so I make an arc here, and then make an arc at this point. Then I'll put it at this last point here. Then make an arc here and here. So let's take our time to get this done well. Okay, so I'm going to number this point on the circumference of the circle. So this point, I will call this point, this is point O here. And this point is point 1. This is point 2. This is 3. So this is 4. This is 5. 6. So this is 7. And this is 8. So here we have 9. So this is 10. And this is 11. Alright, so I'm going to call this point. So this point is point 0 to 0. So let's leave it like that. So the next thing that we are going to do is to connect the point together. So we connect the point together. So we are connecting 1 and 7 together. We connect 1 and 7 together like this. And we connect 2 and 8 together. So 2 goes with 8. Then, so 4 goes with 10. So 3 has gone with 9. So 4 goes with 10 like this. Then we have that 5 goes with 11. Alright, so okay, so the next thing that we are going to do is to take our compass. So we take the compass and we put the midpoint at point O here. So then we extend to 1. So 1 and 11. 1 and 11. So 1 and 11 here. So they are on the same point on the circumference of the circle. So we extend to point 1 here. So we have to take it easy. Then we are going to draw an arc. So the arc will pass through point 11. Okay, so move it. So let's take it easy. Alright, then from O again to point 2. So 2 and 10, so they are the same point on the circumference of the circle. So we draw an arc from here. It passes through 10 and it goes to this end here. Then we extend it to point 3. So 3 and 9, they are together on the point of the circle, on the circumference of the circle. So we draw an arc like this. So it passes through point 9 and it goes to the end here. Okay, then we extend to 4 to point 4. So 4 and 8 are together. So we draw an arc like this. Then 5 and 7 are together. So we extend to 5 and we draw an arc from here. Okay, then we extend it to 6. So from 6, so we draw an arc. So it goes like this. So an end here. So then we come back to the center of the circle. So we need to get the center line or center arc. So from the center of the circle, so we draw center arc like this. Alright, so now, so the next thing that we are going to do is to take a set square or ruler and we draw a line through each of these points. So that is division that we did, division of angle that we did. So we draw a line through each of them. So like this. So it will end here. And we draw from, so this is another point. So we draw from point O here and pass through the point and end here. Then from this point, so we draw. So it ends here. Then from this point, so we draw through this point from point O. So it goes like this. Then we also draw from here through this point, and then from point O again. So we draw through this point. So from point O, so we draw through this point, and from point O again, so we draw through this point. Okay, so then, so we also draw through this point from point O. So from this point also, we draw from point O through that point. Then from point O, we also draw through this point. This. Alright, so then the next thing that we are going to do is that we are going to get the center. So we are going to get the center. So let's number this as this is 1 prime, this is 2 prime. So this, I mean this point on the circumference of the directing circle. So here is 3, so this is 4, this is 5, this is 6, 7, 8, this is 9, this is 10, this is 11, then we have 0. So we start from 0 and we end it here on 0. Then on the center arc that we have here, let's take note of that. So this is center 0. So this point here is center 1. So we write C1. This point here is center 2. So this point here is center 3. So this is center 4. So here is center 5. So this is center 6. So here is center 7. This is center 8. So here is center 9. So we have this to be center 10. And this is center 11. And then we have what we have center 0 here. Alright, so with what we have done now, so we take our compass. So we take the radius of the rolling circle. This circle is rolling. So as it is rolling, so we are going to get the point that's going to give us the epicycloid when we join them together. So we take the radius of the rolling circle, that is 25 millimeters. Then we put our center 1 here. So we make an arc here on arc 1. On arc 1. Then we put our center 2. So on arc 2, make an arc. Then we put our center 3. So on arc 3, so we make an arc. So take note of that arc so that you not mistake it with center arc. So then we put on our center 4. So we make an arc on arc 4. Then we put it on center 5. So we make an arc on arc 5. So on arc 5 here. Then we put our center 6. Okay, so by the time we put our center 6, so we have it at this point. So it will, so it's going to give us, so it will be on this point here. So let's take note of that. So the radius is 25 from here to here. Then we put our center 7. So we make an arc here. So then center 8. So you make an arc on arc 8. So center 9. So you make an arc on arc 9 here. So center 10. So you make an arc here on arc 10. So center 11. So we make an arc on arc 11 here. So we have all these points. So we are going to join all these points together. We're joining this point together to obtain the epicycloid. Alright, so we join the point together. So with the use of a French curve. So it goes like this. Alright, so we take it easy when we are joining together. So we join this together. So it goes with this. So just take it easy. Then, so we connect this together. Okay, so this. Alright, so let's turn to this side for convenience sake. So we join this. So there's a point here which I need to dot. So we connect so this together. Then so we can join these three together. Then so we connect this together. Then we connect this together. Alright, this is the cycloid. This is how, epicycloid. So this is how to construct an epicycloid with the given information that I said here. We need three things to get this epicycloid constructed. We need the radius of the rolling circle. We need the radius of the base quadratic circle. Then we need this angle. So this angle that we have here is this angle. So this angle, so here to here, this is the angle we are talking about. And this angle based on our calculation is 120 degree. Is 120 degree. So it's as simple as I've done it here. When you practice it, you become a master. Thank you and God bless you.